Alright, question 33. Jane wanted to investigate the effect of colored lights on the rate of photosynthesis. So, no need to see already. First up, when it's an experimental question, always remember concepts from your experimental answering technique booklets, which is very important. So the first thing I always tell you all to do is to look at what is your change variable and what is your measured variable. Okay, so in this case, your change variable would be your colored lights, and your measured variable is your rate of photosynthesis. So basically, right, you need to understand right off from the top that usually you cannot measure photosynthesis directly. So you have a proxy. A proxy is something that you use to represent rate of photosynthesis. Now, more often than not, even without looking at this question, right, I already know that usually for photosynthesis, they will look at rate of oxygen production, which is characterized by bubbles or something like that. This is something that I should know right off the top. Don't need to even think so much. Okay? So we can then continue. She prepared small discs cut out from the leaves of plant and exposed them to blue and red lights. So these are my change variable. Okay, as shown in the diagram below. After some time, she noticed bubbles appearing on the surfaces of the leaf disc. As the bubbles rose, the leaf disc were pushed up and floated on the water. The time taken for the leaf disc to float is recorded in the table below. So basically, if you are like pay attention and you are actually understanding what I said earlier, it's here already. Don't even need to think much. Rate of production of oxygen, like what I told you. See, it's here. So guess what? I'm a very good student. I don't even need to read the question. I can predict what is the question going to be. No need to even look at the question already. I didn't know what they want to ask me. So true enough, over here they tell me that A, okay, takes 10 seconds and B takes 8 to float. So remember this, in time is always inverse. The smaller the number, okay, the shorter the time, means the faster the reaction. So this is the part that students always get confused when it comes to time. So why am I telling you this? I'm asking you to be careful. A smaller number doesn't indicate a lower rate of photosynthesis. In fact, a smaller number here means that there is more O2 bubbles produced. So when there's more O2 bubbles produced, right, means that it actually floats up faster. Right? Okay? So, in order for experiment to be fair, state one other variable. Excuse me, ladies and gentlemen, one other variable. Do you not see it? It's so important for you to note. Okay? I mean, even if they don't put one other variable, come on. If it's already listed there, do you think that the examiner really want you to just copy, cut and paste from the question? No. So take a look at what is already there. So they already say things like, okay, both of them have 250 ml, both of them have 7 leaf discs. Please don't go and repeat these kind of things. You know what I mean? And please be specific. I don't want you all to put location of experiment. Please do not write that. I stress. Okay, I stress and I want to emphasize, do not put location of experiment, because that is really very low level of answering, and usually they are not looking for that answer. Okay? Instead, what can you talk? You can talk about the size of the leaf. Okay? You can talk about the type of leaves. You can talk about, okay, even higher level, you can talk about the light intensity, correct? So you can say light intensity. I think that's a good answer. Light intensity of the bulbs, right? So they only tell you what? Red and blue, but they never tell you light intensity, correct? So you can talk about that. Don't give low-level answers like what location. What can, oh, okay, temperature also can. You can talk about temperature, That's also another good one to talk about. What can Jane conclude from the results above? Now, conclude. So remember the last time round, I told you, conclusion question you need to translate. If let's just say the measured variable is not a direct representation of the aim. So what is the aim? Already what? Aim, rate of photosynthesis. Is she measuring rate of photosynthesis here? Will a magic number says something like, oh, rate of photosynthesis means what? No. Instead, what she measured was time. Correct? Time. And the proxy for this is amount of bubbles being produced. So the more amount of bubbles being produced means the shorter the time taken. Okay, so what can she conclude? So she can conclude that B, okay, which is using red light, actually causes the rate of photosynthesis to occur faster. Correct? So red light causes the leaf to photosynthesize at a faster rate than blue light. Now it is very important that you put these two comparison here, red and blue, which some of you never. You know why? You just tell me, oh, red light causes the leaves to photosynthesize faster. Huh? Faster than what? Besides just red and blue, there's also purple light, green light, yellow light, I don't know, cyan, okay? So many other colors, brown. No. So my whole point about it is, you need to tell me exactly what you are comparing with. Next, suggest a control setup to improve. So, control means remove the change variable. Wow, very good. Most of you got this concept, right? You're just very good. You know what you do? Remove the whole light instead. No more light. Yeah, literally conduct the same experiment without light. Huh? No, the change variable is not that one has light and one has don't light. The change variable was that the color of the light was the change variable. Correct or not? The color, people, not whether or not the light was present or was not present. You realize? So it is the color of the light. So you have to tell me that use white light instead. So basically I would say set up as an identical, okay, similar, okay. Okay, no, use the word same. I think same is the safest. Set up a same experiment. The same experiment setup using white light. Okay, so like that you remove away red and blue. Okay, moving on. Question 34. Okay, for question 34, Rita wanted to find out which material would be best for reducing the most amount of light or sound going through. So this is actually experiment again. Okay, so which material reduce the most amount of sound? So just from this statement alone, this is actually the aim of the experiment. Okay, now this is my change variable. No need to see already. From here I can guess they're going to change the material, and then they must have some way to measure the amount of sound. So this must be a measured variable. Okay, she placed an electronic bell inside a box that will ring at regular intervals. She recorded the sound levels using a sound sensor placed outside the box. So think about it. My bell is inside the box. So if the material they should change is actually material of the box. So a material that reduces the sound would not allow the sound to travel upwards, right? And therefore, a good material that can block out sound would means that my sound sensor would find that will record a very low decibel. Okay, decibel is the measurement for noise level. Okay. Next, she lined the insides of the box with different materials. Aha, see, I'm genius like that. Don't even need to read finish whole question. I know already. No need. And recorded her results. See, some level. Wow, genius. No need to think so much. Huh? I am the student, but I'm also the setter of the question. Okay. So even without even looking at the next question, I look at these, I already know. So when there is no material added, okay, it is the loudest. So the best material that can block out the most amount of sound is actually P. So I can actually annotate this. Sorry, my bad. Annotate wrongly. Best, it should be S. Okay, and the worst material should be Q. Right? Because it is the loudest of all the materials, not counting no material. Describe the purpose of using a setup with no material. So, what do you think? No material. So what no material? So this is the change variable, right? So you removed away change variable. So what does it mean? You are actually doing a what? Control setup. Okay? Now, so what do you need to say? You need to say that it acts as a control setup to compare. This one, standard answer must memorize one. I stress again. Compare and confirm, okay, that the change in sound level outside the box is only due to the type of material and nothing else. Okay, this is your change variable. Make sure you memorize. Everybody put star, 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 star. 5 stars here. Memorize this answering format. You can find this answering format inside your experimental answering technique. So if you have looked at it, you will have realized that this is exactly the same. That's why I keep stressing to you that your experimental answering technique is actually very important. So go and take a look at the booklet. Run through my videos on it together with the simplified answer key I've given to you. Next, suggest how using materials of similar thickness allowed for a fair test. So this one, fair test. Okay, now, whenever they tell you something specific, suggest how using materials of similar thickness. Okay, they are asking you specifically thickness over here. You cannot say very generic things like, oh, because it ensures that there is only one change variable. Hello, they talk about thickness. You have to tell me, what does thickness affect? Correct? Okay, so thickness affect, okay, thickness actually talks about the amount of sound that will be blocked out. Okay? Okay, next. Rita's parents wanted to reduce the sound that could be heard outside the house when she plays the piano in her room. Okay, don't know how, then draw. Okay, draw Rita inside. Okay, so she's playing the piano. So you don't want the sound to come out. You don't want. So you need something that is very good, okay, to block out all the sound. So which one? You already put here already, what, right? The best is actually S, because you detected the least amount of sound. So this is actually CER, just in case you didn't know. Okay? So C, material S. E, the sound level detected outside of the box was the lowest. Please use superlative term, lowest. Okay, this suggests that S was able to block the most amount of sound. And then your R. By using S to line the walls, the least amount of sound could be heard outside the room. Okay, so can you see how I relate? First, I talk about material S, then I show them the evidence. Then after that, detected by what? Detected by the data logger. Okay, make sure the word detected is there. And then after that, what does this tell me? This tells me that S was able to block out the most amount of sound. So because it's able to block out most amount of sound, right? So by using it, right, the least amount of sound could be heard from outside since it blocks the most. Okay, can you see how logically linked it is? You have to learn how to write CERs that are like that. Next. Okay, now this question, I want everyone to focus, really focus on it, because this is a common question. Already so common until I have nothing else to say, but yet many of you got this wrong. Okay, now this topic, right off the top, I can straight away tell you, right, one look at it, I know it's on water cycle. Now the reason why you all fail to do this question correctly is you always fail to identify where does your water vapor come from, okay, and where is your cooler surface. It's very important. So whenever you deal with water cycle, you always ask yourself, what is the concept here? So the concept here that is tested, that is being tested, even when I don't read the question at all, I'm not reading it, okay, I see words like white mist. If I can see it, it means that it cannot be water vapor. It must be condensation. Okay, or rather it must be water droplets because I can see it. You cannot see water vapor, right? So it has to be water droplets. And if there's water droplets, I know that condensation must happen. So if I know that condensation must happen, I know that I need to have two things. Number one, I will need a source of water vapor. Correct? Because water vapor needs to touch a cooler surface, then it can condense to become water droplet. Next, I must have a cooler, okay, surface. I need to know what is this. These are my two most important things to identify. So without even going into the question, I already at the back of my mind, I know what's going to happen already. And this is what you need to do in exam. You cannot fail to get this question wrong. It has to be full marks and nothing else. Come on. It's such a common question. So I say again, first things first, can you see the substance? If the answer is yes, it has to be water droplets. There cannot be another way around it simply because you cannot see water vapor. It's a gas. Can you see the water vapor in the air now? Cannot, right? So if they tell you can see, means water droplets and condensation must have happened. Now we read the question. Sophia wanted to conduct an experiment with ice cubes. She took out a container of ice cubes from the freezer and observed there was white mist appearing above them as shown. Okay, explain how the white mist was formed above the ice cube. So remember, you need to answer these two questions and you know that condensation happened. Now, the white mist is actually water droplets that is formed over here. It's in the air. What happened? That means my condensation must have happened in the air, not on the ice cube. So many of you tell me, lost heat to the ice cube. Wow. If it loses heat to the ice cube, then my water droplets would be on the ice cube, isn't it? Not in the air, what? You should see the white mist. In fact, it's not white mist, it's just water droplets on your ice cubes then. No, but what did the question say? The question say in the air, right? So how could it be on ice cube? So no, your ice cube is not the cooler surface. So what has actually happened was that because the surrounding air has lost heat, okay, to your ice cube. So now the surrounding air, okay, is actually cooler. Okay, the surrounding air that is near your ice cube is actually cooler than the surrounding air, the water vapor in the air that is further away. Okay, the most immediate surrounding area here, right, near the ice cube, right, will be very cold, the air. So this air here is actually cooler than the air that is further away. So the warm water vapor from the air that is further away would then be able to lose heat. Can you imagine that? Okay, and that was what happened. So the warmer water vapor, so I'm going to divide out this. So this is region A. I'm going to use a highlighter. Region A is the further away one. Okay, and then after that, this is region B. So region B is nearer to the ice cube. So the region B surrounding area here is cooler than region A. Okay, and the water vapor from region A would then lose heat to region B. And then it will condense, okay, in the air, losing heat to the cooler air surrounding the ice cube. So how will your answer look like? Okay, so warmer, remember warmer and cooler, warmer water vapor in the surrounding air outside the freezer touched the cooler surrounding air around the ice cubes, lost heat and condensed to form tiny water droplets. Now these tiny water droplets are so tiny that they are suspended in the air as white mist. So this is what you should do, bracket white mist, to let the examiner know that you understand. It's because the tiny water droplets are so small until it's suspended in the air, it's hanging in the air, floating in the air like your clouds. Okay, get it? So please, it is not it doesn't condense on your ice cube. It condenses in the air because the white mist is in the air. And this question was a very similar question, okay, in one of the PSLE question. So get it right, don't get it wrong anymore. Next, okay, in winter, substance T is put on the road to make ice melt. Sophia conducted an experiment by putting the same amount of ice cube in two funnels and adding substance T to the ice cubes in the funnel at setup B. Okay, so then they ask you, the ice cube started to melt. Sophia measured the amount of water in each cell every 10 minutes. So once again, this is your measured variable. Okay, and then what is actually your your change variable? Your change variable is basically whether or not your substance T is present or not. This is your change variable. Okay? And then actually translation needs to be done. Amount of water, right? Guess what? What it means? The higher the water means the faster the rate of melting. Right? When you think about it, because ultimately she wants to find out whether or not substance T is affecting the rate at which your ice cube melts. Based on the graph, what was the effect of substance T on melting the ice? So in setup A, you realize that setup A has no substance T. So over here, can you see it took some time before it starts to melt? Okay, or maybe it started to melt. Okay, oh no, haven't even yet. Okay, because zero amount of water collected. So for setup A, right? Okay, the amount of water only started collection at 10 minutes later. Okay, this is without T. So in exam, you can actually annotate like that with T. So it's easier for you to look. So you would know that, oh, this takes a longer time to eventually reach a higher temperature. Whereas the other one, right, wow, straight away at 0 seconds start to melt already with T. So it's very telling. Okay, so substance T increases the rate of melting of water. Okay, or ice melted faster when substance T was added. Okay. Now, Sophia said that she was able to conclude the effect of more substance T on the melting of ice. Her results in the graph did not support her conclusion. Suggest what she should do to arrive at her conclusion. So what happens is that the word here is more substance T. Right? More. So in this case, ask yourself, what is the difference between this statement, more substance T, and this experiment here? This experiment, right, you can only say that, okay, did they even say here? Okay, it didn't say, but I can tell you that you look at this experiment, right, there is only with substance T and without substance T. So you can only say that with substance T, your ice melt faster, but you cannot say that with more substance T, it will melt even faster, right? For all you know, you put 10 scoops of substance T and you put 1 scoop of substance T, it is still the same rate. You know what I'm saying? It is still the same rate because you have not tested it out. So there's this very nice phrasing that I just learned recently with regards to COVID experiments. They say an absence of experiment does not mean an absence of results. Just because you did not test it out doesn't mean that it's not true. Conversely, this is also the case here. This doesn't mean that just because you tested it out, okay, it will be the same for every single experiment that you do. The more you add, the more it becomes. No, because you could add 10 scoops, it can still be the same. Add 20 scoops, also the same. You see the difference? So what she needs to do is, she needs to repeat her experiments with varying amounts of substance T. She needs to repeat the experiment with varying varying amount of substance T. Okay, and then so if the graph shows that as you increase more and more substance T, and it takes shorter and it takes a shorter time to melt, it means that yes, with more substance T increases the rate of melting. If it remains the same, it just means that no, it doesn't. Okay, it's just a one-time thing. It's either a yes or a no, full stop, done. Okay? Next, Imran built a puzzle circuit with identical battery bulbs E, F, G, and H. He covered the connections to the bulbs with a card as shown below. The bulbs could be seen through the card. Okay, through the holes in the card. All the bulbs lit up when the circuit was closed, but their brightness was different. So this tells me that means there are two different kind of arrangement here, parallel and series. Okay, this will already hint me different arrangement of what? Arrangement of bulbs. Be very careful when you talk about parallel and series. You cannot just say, oh, the bulbs are arranged in series. Which bulbs? Okay, parallel. Don't say A and B are arranged in a parallel circuit. No, bulbs A is arranged parallel to bulb B in a circuit. Be very careful because your bulbs can be parallel to the battery also. He then removed one bulb from the circuit each time and observed what happened to the rest of his bulbs. His observations were recorded in the table below. Okay? So when bulb E was removed, none of it lit up. That means, very simple, bulb E must be in a common pathway. What do I mean? Common pathway means if I have something like that branching. Okay, say this example, this is A and this is B. So my E, okay, so if electricity flows this way, the common one would have been something like this. This could be E. Could be example. Why? Because the minute this is gone, this is open circuit. These two also will not light up. You know what I mean? So this is a common pathway. Agreed? So the arrangement, my E, when I put it in an arrangement, definitely needs to be a common pathway. Don't you see already? Okay? And then they tell me, okay, if I close, okay, F, E and H will light up, G, E and H will light up. That means these two must be in parallel. F, at least I know F must be parallel to E and H. G also must be parallel to E and H. Why? Because if these two are crossed out, it does not affect these two. So they must be in parallel. Right? So write it down. Then after that, when H is removed, okay, E, F, G is not affected. So this must also be in parallel. It doesn't affect correct? So let's take a look. Complete the circuit below to show how the four bulbs. No need to see already. Already tell you that E is the common one. So E stands alone. Then after that, they went on to say that when F is removed, E and H lights up. So I'm looking at something that is like that, isn't it? Okay, whereby E is the common one. So if E is out, everything does not light up. Checked. Okay, I say already, F needs to be parallel to E. Can you see F is so-called parallel to E and H? But I never say cannot be in series So G does not light up because when F is out, electric current cannot flow through this whole pathway. But my E and H still continues. No issue. Check. Next one, G. Similarly, when my G is out, okay, I cannot flow through this pathway because there's a gap here. But I can still flow through like this. So my E and H will still light up. Checked. H. When my H is out, it can flow through this way. Checked. So you need to actually write all this down to help you identify. Draw these kind of things to help you understand what does it mean. Okay, and then you can actually come up with the drawing very easily. I demonstrated this before previously also. Okay, how does reading it and then talking yourself through actually help you simplify your drawing? And actually, what you can do is you can quickly sketch it out and then use a ruler to redraw all the lines later on at the side. You can do a rough drawing at the side. Now, be very careful. A lot of you thought that this was wire. This is not wire. You know, a lot of you drew this, you know, wow, straight away drawing from here. This is not a wire. This is the card. So read carefully. Okay, next. Imran added a switch to the electric circuit in A so he could switch off all the 4 bulbs at the same time. Write an S in the circuit diagram to show where the switch could be. So you want to switch everything off, right? So very simple. Make sure it's a common pathway. So very simple law, you trace. Anywhere around here, this highlighted part is a common pathway. So anywhere around here, you put a S. Okay? The whole entire circuit will not work anymore. It's as simple as that because this is called your common pathway. Next, if only S1 was closed, what will happen to the brightness of B1, B2, B3? I tell you, right, even straight off the top, right, they are asking you, every time I see this word brightness, I know it's hinting to me already. The only thing that affects brightness is 2 things, okay? One is number of batteries. 2 is arrangement of bulbs. No need to say already, they're testing me on this. So did they actually change the number of batteries here? No. So obviously they must be testing me on arrangement of bulbs. So, okay, give a reason. Okay, so X is here. Okay, what would happen to brightness of B1, B2, and B3? So, if you put another bulb here, okay, and you close S1 only, trace, you will notice that this is what? Actually a series. And you know that in series, okay, your bulbs become dimmer because the amount of electricity coming out from the battery is shared among the number of bulbs that is within the same series, one after another. So at first there was only 3. So if you add 1 more, you have added in the 4th one. It's just like if you have 10 cookies, okay, at first you share with only 2%. Now I tell you, you need to share 5%. So how many cookies do you get? You get only 2. At first, when there's only 2%, each person get 5. Now each person only get 2. You got it? That is series. So what would your answer be? Okay. B1, B2, and B3 would be dimmer. Okay, that will answer the question. Now must explain why the bulbs are arranged in series and less electric current was flowing through each, I repeat, each of the 4 bulbs. Okay, because they are so-called sharing. Alright?